It is a known fact that Docker requires root privileges to do anything. Then how does adding a user to the Docker groups removes that requirement? For instance, I can do Docker PS, I can create Docker containers without sudo as a non-root user, but that should not be possible. Okay. And not just that, the entire ecosystem around Docker actually requires root privileges. And just to showcase, we can grab everything which is related to containers. I think that would work. Yeah. As you can see, the container D is running with root. Then we have Docker D, which is running with root. And the most fascinating one, like 41C, the container is also running with root user, even though I created is as a Ubuntu user without using any sudo. So first of all, you need to understand the reason everything is running with root because of Docker D. Okay, Docker architecture is a client-server architecture. So your Docker CLI here is a client and Docker D is a server. And Docker D is always running with root privileges. Always, okay? It starts when your system starts. So it gets executed by systemd servers, okay? Which is docker.servers. And that's why it is always running in the background with the root privileges. So whenever you are running anything, okay, like creating a container, Docker CLI does not do that. Okay, actually, you can replace Docker CLI with many things like a programming language, a different tool, or a GUI application like Portainer. So there are many things that you can replace your client with, and they all will communicate with Docker-D to achieve the same task. Okay, so the question is, the question remains, how does then Docker CLI communicates with Docker-D? Because at the end, Docker CLI gets all the requirement of the user and send it to Docker-D. But that should not be possible because at the end, I am running this command with Ubuntu user and I cannot talk to a root privileged process. And that is true. And that's where the the concept of inter-process communication and Unix sockets come into the picture. So let me just show you, okay? I am part of Docker's group, okay? And anybody who's part of Docker group actually can access a very special file, which is available under run as docker.sock, okay? It could also be where run docker.sock. And this file, anybody who's part of Docker group, which I am, can access this, or root user can access this. It's a socket file, as you can see. So it's a socket file. So whenever you execute anything like Docker PS actually creates a socket and connects with this file descriptor. Okay, and your Docker Docker Daemon is listening on the same file. Okay, and reads. That's where they communicate with each other. So to go into more detail, I will show you how this is happening behind the scene. So let's check this out. Sudo systemctl, and we can say we have docker.service, which is running with root privileges. We already know that. And this is the service which keep running dockerd in the background with root privileges. And it get triggered by docker.socket. Okay, it's a different process. So let's go ahead. Okay, and check this out. What it does. Can I cat it? Okay, so it is listening on run.socket, the same file descriptor that I mentioned. It is listening for dockerd. And now let's check out the Docker service file. Okay, what the Docker service, which I mentioned, executes dockerd. And as we can see, the docker.service file starts dockerd when your system boots, and there is a fd, which simply means the file descriptor. Okay, and now we are here telling dockerd not to create its own file descriptor, instead inherit from the systemd, in your case parent process, which is the systemd service. Okay, so inherit from it. And where does it inheriting from? The same that I just mentioned recently, docker.socket. Because so in a way, Docker C, okay, so in a way, let me just clear it. Clear. And I want to give you an UI again of ls minus la, okay, and ps. Forget about ps. Okay, so in a way, what is happening? Your Docker CLI connects with this file descriptor, okay, with this socket, and your Docker D is always listening on the same file descriptor for any instructions. But the questions again, can you prove that? Can you show me? Of course, I can show you by making you review the code. At the end, it's an open source tool. Anybody can go ahead and look into it. We will do a little bit differently, okay? I will try to trace the system call Docker process or Docker CLI makes whenever I give them any command. So I hope you will understand it when I do it. So I want to trace anything network related. Okay, sockets comes under the category of networking. So, and we can say docker.ps. Okay, so what I'm saying is trace any system call related to network when I run docker.ps. And as you can see here, I created a Unix socket. Okay, so in this case, we are using Unix socket. There are different type of sockets, and we are using our communication medium as a file descriptor, which is where run docker.sock. Okay, and once I'm connected to it, the Docker D will accept it and send me this output, which I am getting here. And one more thing, why we are using sockets? So it's a way of enabling inter-process communication between two processes. Okay, there are other ways to achieve the same thing, but in this case, we used the file descriptor. Docker decided to use file descriptor and sockets. If it was on another system, we might be using TCP for that. And yeah, by the way, inter-process communication simply means it's just a fancy way of saying two processes can communicate with each other. Okay, your browser does it. There are other tools that does it in different manners. So now we get okay, Abhishek, I got it. When we run Docker PS actually connects with the socket file, which is available here. You can call it file descriptor, and Docker D accepts it. Show me. I don't believe it. Yeah, that's a good mindset. If we can prove it, it is happening, then that would be really amazing. So okay, don't do that. Don't do that. MP shell. So the command would be a little bit different than this because this command exit, it's not a continuous. Docker D is a continuously running process in the background. So first of all, we need to get its PID, process ID for Docker D. And it's 829. And what we can do is probably as trace, yeah. And I always forget it. Trace network, then from what I remember, 29, something like that. It didn't work. Process now, okay, sudo. So yeah, I think it's working now. So now I will try to run the same command here. I should see a connect, okay, docker socket.connect, and here I should see socket.accept because in this case it's a Docker D, which is a server. In this case, it's Docker, which is a client. I don't know why did I even say that. Does not really make sense. Okay, yeah, but forget it. Forget my last two lines. I'm not gonna edit it. So as you can see, I did the same thing which I mentioned before. I'm doing docker socket.connect with the file descriptor, which is docker.sock, and I'm getting this response from Docker D because Docker CLI just parses things, don't do a lot of things. And here we can see we accepted, okay, as we were supposed to, we accepted, okay, a Unix socket which tried to communicate because Docker D is always listening on the same file descriptor, okay, and we send the response, whatever we're supposed to send it. In this case, it was running container at present. So I hope now you got my point, what I wanted to share. Uh, so the idea here is, if I have probably a diagram, but I should have created a better diagram, but I think this would work. So what is happening? Your Docker CLI even does not have root privileges, communicates to Docker socket, okay, by creating a socket, and Docker D also listens on the same socket. So in a way, Docker CLI writes to it, Docker Daemon reads from it. That is not the case, okay? That is not the case. That's not how socket works. I'm just giving you an analogy. Analogy. Forget. Um, and then Docker D will do anything that Docker D wants to do. Anything that Docker D executes will gonna have a root privileges, because we inherit from the parent process. So that is the whole thing. That's how the communication between Docker containers, the client and server happens. And that's why Docker can create, run, or show information about containers without sudo and as a non-root user. I hope you liked it. I hope you didn't find it very confusing. If you did, watch it again. If you still find it confusing, tell me again. I'll probably try to create in a different manner, maybe in 2 parts or something. Have a nice day.